title of this notes is multiplying and dividing fractions. So your outcome is I can multiply and divide fractions, specifically with variables. So how do I multiply fractions? So just like our last set of notes, I'm going to start with numerical fractions that we're more familiar with. So let's multiply 2/3 times 3/4. When you multiply fractions, remember you never ever want to say cross multiply. That is incorrect. What you're going to do is you're going to multiply the numerators. So 2 times 3, and you multiply the denominators. And then I see that this one simplifies, 6/12 simplifies to 1/2. So you are multiplying across. It's a little bit different from adding and subtracting. You might remember that adding and subtracting, you only added the numerators. You did not change the denominators. When you are multiplying and dividing, you multiply and divide both the numerator and the denominator. So let's look at an example of how to do this with a variable. So take a look at the first problem. We are going to multiply across. So multiplying the coefficients, 2 times 4 is 8. And then m to the 5th power times another m is m to the 6th power. You might remember your exponent rules here. This is like m to the 1st power, and when you're multiplying, you add the exponents together. And then the denominator, 3 times 3, is 9. So there is a nice simple problem, but as you see below, number 2, these problems are not always so nice and simple. So let's look at number 2. All right, I really don't want to multiply all of that. It looks pretty big and scary. So what I'm going to do instead is I'm going to factor, see if I can make this look a little less intimidating. So starting with the first fraction, x squared plus 20x plus 100. So I'm going to ask myself, do I know any factors of 100 that add up to 20? So I'm thinking, well, 100 is 10 times 10. Oh, and 10 plus 10 is 20. So that first fraction is actually x plus 10 times x plus 10. And then in the denominator, I see GCF. Both 8 and 80 are divisible by 8. And both x cubed and x squared are divisible by x squared. I'm going to factor out 8x squared. And what that did for me is I said, hey, wait a second. X plus 10 as a factor appears in both the numerator and the denominator. X plus 10 divided by x plus 10 is just a fancy form of 1. So this is like saying times 1. I don't need to say times 1, it's redundant. So this rational expression is equivalent to x plus 10 over 8x squared. So now let's look at the second fraction. Again, let's try factoring it. So factors of 54 that add up to negative 15. So right away I'm thinking both of my factors need to be negative, and I'm thinking negative 9 and negative 6. That'll be multiplied to be positive 54, add to be negative 15. And then in the denominator, multiples, factors that multiply to be negative 60. So if I'm going to get a negative product, one of them must be positive, one of them must be negative, and they need to add up to be positive 4. So I'm thinking 60 is 6 and 10, and if I make the 10 positive and the 6 negative, that'll get me to my positive 4. So again, I notice, hey look, there's a factor that simplifies to 1. Isn't this a lot easier to multiply? I see something else. When I go to multiply these together, and I'm going to go ahead and do this, x plus 10, I'll multiply the numerators together. Here, let me write out every single step so you can see very clearly what I'm doing. That's the same problem, just with the 1 factored out. And then I'm just going to multiply the numerators and the denominator. I'm not actually going to do the multiplication just yet. I'm just going to write it like that. So it's one big fraction. And I notice there's something else that cancels out. Yes, I could FOIL that numerator, and I could distribute that denominator, but I don't have to because the x plus 10 factor now appears in both the numerator and the denominator. So again, x plus 10 divided by x plus 10 is like 1. So our final answer is x minus 9 over 8x squared. So that problem that looked really intimidating and scary, there was actually no multiplication to do. It was actually an all factoring question. So on the next slide, there's 2 for you to try. Here's 2. Take a moment to try these. Remember, start with factoring, see if you can simplify, and they're the answers so that you can check your work and bring your questions to class. So now that we've talked about multiplying, we're going to talk about dividing fractions. So what happens when you divide a fraction? So let's say we have 2/3 now divided by 3/4. How do you divide 2 fractions? Before we get into the division, I want to have a little side conversation here. What does it mean to divide something by 2? If I'm going to divide 10 by 2, that means I want to put 10 items into 2 groups, and each group has size 5. I could rewrite division by 2 as multiplication by 1/2. 10 times 1/2 is also 5. How do I know that for sure? Turn the 10 into a fraction, and just like we just saw multiplying fractions, 10 over 2 gives us 5. So what I want you to notice here is that dividing by 2 is the same thing as multiplying by 1/2. So if you convert division into multiplication, you can do that so long as instead of using the value, you use its reciprocal. So the same holds true here. If I have 2/3 divided by 3/4, dividing 2/3 by 3/4 is the same thing as multiplying by the reciprocal. Just flip that fraction. And now it's a multiplication problem. So whenever you are dividing with fractions, it's always a best bet. Just change it to the reciprocal, turn it into a multiplication problem. All right, so here we are with some variables. So we have 8 over 5n divided by 10n squared over 5. We're going to rewrite it as a multiplication problem. And before I even do the multiplication, I notice I have a factor of 5 in the numerator and the denominator that will factor out. Save myself some time. And I see that 8 and 10 have a GCF of 2 that factors out. So there's my simplified answer. So then again, trying this in number 6, a little bit more intimidating, but we learned last time that if we just factor, we'll get there faster. So the first fraction, I see a GCF of 40. And in the denominator, 70 and 50, both divisible by 10. And then this division, we're going to turn it into multiplication. And so now this is the numerator, 14n plus 10, and it has a GCF of 2. And the denominator is now 40n minus 80, which has a GCF of 40. So now multiplying, let's see if we can save ourselves some time. I notice 7n plus 5 is a factor in both the numerator and the denominator. Factors out. I notice 40 in the numerator and the denominator. Factors out. So now we have 2 times 2 minus n all over 10 times n minus 2. We can simplify this even further. I notice these factors are awfully similar to each other. Here I have a negative n and a positive n, positive 2 and a negative 2. They're almost the same, except the signs are flipped. So we can actually rewrite this top factor. We can factor out a negative 1, and it becomes negative 2, positive n, and negative 2. And the point of doing that is we see the factors are the same, and again, factor out. Whenever you have factors that are almost the same, just subtraction when the order is different, you can actually cancel them out and leave behind a factor of negative 1. So those factor out, leaving us with negative 2 over 10. And again, there's another GCF of 2. So our final simplified answer is negative 1/5. All right, the last part of this is you now have 2 of these to try on your own with the answers. Bring any questions you may have about these to class.